Hello madam, I'm Omprakash. I'm from Triple The topic is about diagonalization problem on non-repeated roots from control systems. Here the question is diagonalization or transfer function of matrix. Consider the state equation of the system of x minus ax, x equal to ax plus b mu, where x is the state variable vector of order n into 1. Let us define a new variable z such that x equal to mz, where x equal to transform state vector and m equal to model matrix or diagonalized matrix. The state model of the system can be given by x dot equal to ax plus du, and next y equal to cx plus du. Then substitute x equal to mz in above equations. Here the equation is substituted by mz in the above x dot next y equations, and then finally we get x dot equal to amz plus du, and then y equal to cmz plus du. Next multiply with m inverse, we get m inverse of x dot equal to m inverse amz. There x dot is replaced by, x is replaced by mz, right? And here m inverse x dot equal to m inverse amz plus m inverse bu, and then m inverse y equal to m inverse zmz plus m inverse du. Here 0 degrees equal to m inverse amz plus m inverse bu. And here is the problem of non-root. And the question is, a linear time invariant system is described by the following state model. Here the question is x1 dot x2 dot x3 that equal to matrices of 0 1 0 0 0 1 and minus 6 minus 11 minus 6, and x1 x2 x3 plus 0 0 2 of u and y equal to det 1 0 0 of x1 x2 x3, and transform this state model into diagonalization matrix. Here the solution for this diagonalization matrix, A equal to matrix of 0 1 0 0 0 1 and minus 6 minus 11 minus 6. Here it was written from the question. And next det xi minus a equal to 0. Again a matrix lambda 0 0 0 lambda 0 0 0 lambda minus matrix 0 1 0 0 0 1 and minus 6 minus 11 minus 6 that equal to 0. And again matrix of by subtracting we get here matrix lambda minus 1 0 and 0 lambda minus 1 and 6 11, and next in lambda plus 6 into equal to 0. Here we get the equation lambda uh, into lambda plus 6 plus 11 plus 1 into 0 plus 6 minus 0 equal to 0. And next lambda cube plus 6 lambda square plus 11 lambda plus 6 equal to 0. By multiplying we can get this equation, and by solving we get lambda equal to minus 1 minus 2 minus 3, and next lambda equal to minus 1. Here we substitute this one by one. Lambda equal to minus 1, let us assume matrix minus 1 minus 1 0 0 minus 1 minus 1 6 11 5. Here we taken minus 1 from lambda, and next C11 equal to minus 5 plus 11 equal to 6. Here we get this by multiplying the matrix, and next C12 equal to 0 plus 6 that equal to 0 equal to minus 6, and next C13 equal to 0 plus 6 that equal to 6, and next here M1 equal to det C11 C12 C13. that equal to 6 minus 6 6. Here we get this from above matrix, and that all equal to we can get 1 minus 1 1. And next step is lambda equal to minus 2, and from here we can, from before equation we assume that lambda equal to minus 2, and now here next step we can assume minus 2 in lambda place. Here's the matrix, and C11 C12 C13, and by multiplying and adding we can get m2 equal to C11 C12 C13 of det, that equal to 3 minus 6 12, and here we get 1 minus 2 4 by dividing all. And next like 1, like lambda equal to 1 and minus 2 equal to we can do this lambda equal to minus 3 as the same process of before two equations. We get lambda equal to minus 3, that equal to m3 equal to det of C11 C12 C13, we can get 1 minus 3 9, and here m1 m2 m3 that equal to, let us assume in, let us arrange this in matrix. M inverse equal to matrix of 1 1 1, and next minus 1 minus 2 minus 3 and 1 4 9 of matrix inverse, that equal to, here we get by multiplying this step, and we know that m inverse of am equal to matrix of 3 2.5 0.5, and next minus 3 minus 4 minus 1 1 1.5 0.5. By multiplying and adding we can get finally one matrix of 1 1 1, and next step minus 1 minus 2 minus 3 and 1 4 9. This is the problem of diagonalization method. Thank you.